Hello and welcome to the first of two in a series of VMD tutorials. In this tutorial, I will take you through how to open and basically get a simulation loaded and in a more pleasing visual setting. And in the next tutorial, I will show you and walk you through how to essentially manipulate the graphics of the tutorial and a series of representations to better orient whatever research purpose you may have in loading that simulation. So the first thing you need to do is just simply open VMD. I've already done so. However, you might do it on your operating system might be different, but for me it's just clicking over here on the toolbar and VMD opens and it gives you a terminal window which essentially opens up and isn't too important, and then a visual window, which I've already got a simulation loaded in, and then kind of a command window here, which gives you your different options of things you can do, similar to a toolbar on any other program. Now, the first step is to go over here to File, and in this case, you would want to click New Molecule. And again, like I said, I've already loaded a molecule in here just for purpose, and you'll see why I did that. But once you go over here to New Molecule, you will want to click over on this Browse button, and I've got my hard drive attached, and I've got in it a bunch of different files, but the one you're going to look for is first and foremost to open up your the DCD and the PSF file. There are two types of files that will load a visualization model into VMD. You need to load both of them, and you need to load them, but you have to load them at different times. So I usually do the DCD first and then the PSF. It really doesn't matter which order you do it in. But once you simply click that, click open, the last thing you need to do, it's basically, this is the DCD model, you would hit load, and your simulation would begin to load. Once you do that and you do the PSF molecule, you will have something that looks like this in a stick figure orientation that will essentially just wiggle a lot, and it'll actually individually load every single frame, and you can watch it load every single frame of that model. But once it stops, this one in my particular case had 10,000 frames, so once you wait to all 10,000 frames to load, you're sitting here with this nice stick figure orientation. And I'm going to move this over here so we can kind of see it both at the same time. But now, this is really kind of complicated to see. Somewhere in here, there is a ligand in the middle of the molecule, and then there's the protein itself. And right now, you can't really differentiate that. But we will fix that, because if you go over here to Graphics and click Representations, you can essentially tell the program to highlight and do different visual representations of different portions of the molecule. You actually have under the Selections tab somewhat of a cheat sheet of different commands or keywords you can give it. One of the easiest ones that you can do is segname. Segname essentially differentiates between the different segments that are loaded in your representation, and in this particular case, DSCB is the protein, and Lig1 is the generic name of the ligand within this protein. So what we're going to want to do is once I click this, you see segname appears in this box here. I could have actually typed that in, but I would have had to type it exactly like it was seen as segname. But for this purpose, I'll just go ahead and type in, show you that, prove that it is possible. I will type in DSZB, and what I want to do now is click enter. So we've loaded a representation, but this representation right now is lines. So it's what it already came kind of preset as. So we haven't actually changed it. But now that it is its own representation, we can go back here to Draw Style, and we can select what we would like to do with it. So specifically, for a protein, I normally like to do what's called New Cartoon. So once we hit New Cartoon, there you see we have essentially changed what this looks like. And we've gone from an ugly stick figure representation to a much more pleasing representation. You can even see the helixes and sheets that are generally found within a protein structure. But you also might notice that our ligands disappeared. There's nothing in that. It's actually there, we just haven't created a representation for it. So what you're going to want to do is click Create New Rep, and you'll see essentially it just copies the representation that was in front of it. So there's nothing new here yet, but what we can do is take this second rep and we can change from segname DSCB to segname lig1. Now, we can also see that that really didn't do much yet, but once we click licorice and hit enter, well, I think it showed it before that, now you see we have the ligand. This happens to be 2-bicarboxylic acid, 2-bi-phenyl carboxylic acid, and it is found in our protein structure, and it is differentiated as it's in a licorice drawing method as opposed to the new cartoon. So here, this is much easier to see than those stick figures, and you now have a fully functioning representation and simulation loaded. And it's also important to note that all I'm doing here while I'm moving this around is just clicking my mouse, and it's just rotating on any of the XYZ axes here. So that's all for this first video. In the next one, I will show you and walk you through some steps with how to manipulate it and some different techniques to better get a sense of what's going on within this representation, and highlighting and pointing out specific areas that you can look at and differentiate them further. Thanks, and see you again.